Hello everyone, my name is Árpád Jorzsits, and today I have the pleasure to open our next event called AWS Day Budapest. I'm excited because after Google and Microsoft, we finally dedicate a half-day session to the great platform of Amazon Web Services. We handpicked a lot of excellent speakers from all around the world to talk about topics like CI/CD, chaos engineering, infrastructure as a code, or applications running on cloud. Before we start, I would like to say thank you to our sponsors, Deutsche Telekom IT Solutions, T-Systems International, and of course, Amazon Web Services. I hope you will enjoy the day.
Hello and welcome to Do Awesome Things with Infrastructure as Code. My name is Darko, and today we will, before we start, I need to flip to something here. Well, first of all, I need to show you. You need to see this bigger, right? Before we start, let's go. I'll come back to this in a moment. All right, let's talk about infrastructure as code. Well, actually, let's talk about you. Who are you? What are you doing here? Well, here's the thing. You are a developer, a builder, an engineer, an architect, a system administrator. You build systems for your team. You build development environments. You build staging environments. You build production environments. And you've built up this amazing system that satisfies all of your developers, the staging system that kind of imitates an exact production system, which is wonderful. You did that. It's a Friday afternoon. You give it to your developers. You get home and you get a phone call saying, wow, this is amazing. This staging environment is excellent. You feel great, don't you? But we need 5 more. They need 5 more of the exact same thing. Now you have to go back to the office on a Friday evening and provision 5 more staging systems because the developers, the product team, wants to deploy something by Monday. Not a fun Friday afternoon. So let's talk about something that can help you with that and a lot of more things. And something that can make your life better. That's the whole point. So let's talk about infrastructure as code. Or what is infrastructure as code? First of all, let's answer that question. This term is being thrown around a lot. The acronym is IAC, so infrastructure as code. But let me explain this through a Darko example. So a long time ago, so 10 years ago when Darko was younger, had more hair, and I was working as a server provisioning administrator. And my job was to provision physical servers to remote locations all across the world, from your Frankfurt data center to Fairbanks, Alaska. That was fun. Somebody would rack a server for me. I would set it up. I would install the software, configure users, set up backup, set up storage, application installs, all of those things. And it was just great, right? It was fun, right? Well, it was fun for the first time. If I had to do this 500 times, and I had to do this 500 times, I would make mistakes. I would, misconfigure things. I would not do the things the way it should be done, and I would have to repeat myself all over again. Things have changed since then. From me manually configuring backups and users, we've moved to provisioning systems, configuring systems through code. Yes, the wonderful world of code. This has made mine, hopefully yours, life so much simpler. Instead of provisioning systems by manually typing things into a console or, forbid, clicking onto things, it's much easier to do it like this because you codify things. You express things in a wonderful text file, which is easy to read, easy to understand, and everything is being done in the exact same way. Simply put, infrastructure as code allows you to provision your infrastructure components, your compute, your storage, your databases, your network components through the wonderful means of code. Why? Why is that great? Well, it's predictable and repeatable. If you want to do something 500 times, just do it 500 times. Run the same piece of code 500 times. You can use all the wonderful built-in developer tooling, your pipelines, your testing frameworks, anything you want. You can use the same thing for your infrastructure provisioning, which, yeah, you can treat your infrastructure code as application code, as any other code. And finally, replicating production into staging environments, actually replicating any piece of infrastructure to some other piece of infrastructure is also quite possible. So if you remember from the beginning, yeah, creating staging environments out of production environments manually, it's never the same. So being able to replicate something, basically just copy it into something else, and having almost a carbon copy of a production environment is just chef's kiss. Wonderful. So this is infrastructure as code. This is quite important, and this is something that can help you, the developer, the builder, the engineer, achieve, well, at least a better Friday evening, if anything else. To explain who I am and why am I yelling into the camera, my name is Darko Mesaroš. I am a long-time builder. I used to be something they call a system administrator. I used to maintain Windows systems, Linux systems, Solaris, AIX, HPUX, all of the wonderful systems a long time ago. And one of the passions I have is towards automating stuff. So I like to automate. I like to make sure things are automated, but at the same time safe. So I've done that for a long time, and I want to translate that knowledge to you, our wonderful builders and developers. I happen to work for AWS as a developer advocate, and I'm based in Berlin, Germany. I'm also from Serbia, so hence the different spellings. If you want to follow more of me, there's the social media stuff. I tweet a lot, I LinkedIn a lot, I Twitch and YouTube a lot, I guess. So yeah, I would be happy to have you there. Let's continue to the important things. What today is all about. We're going to talk about building your infrastructure code. We're going to be talking about testing your infrastructure code. And we're going to be talking about deploying your infrastructure code. This is wonderful because this is what awesome things are from your infrastructure code. You can do these things. Well, of course, they make sense, right? But I'm going to give you some examples how they can kind of improve your life as an architect, as an admin, as a DevOps engineer, if such a thing exists. So first of all, let's talk about building stuff. When I say building, in this sense, it's not a matter of connecting cables to things. It's a matter of connecting different bits of code to different purposes. So when we talk about building stuff, we talk about using different frameworks to build your infrastructure, right? In this case, we talk about something like AWS CloudFormation, which is a wonderful framework that allows you to build your infrastructure through the power of YAML and JSON. You build these static declarative templates, which basically you, as a cookbook, you define what exactly you want to exist. This is not a script. This is not a bash script. This is not a PowerShell script. This is a YAML file or JSON where you describe what you expect your infrastructure to be. For example, I want a VPC. The VPC should have DNS support enabled. Should not have DNS support enabled. I want to have an EC2 instance. I want this EC2 instance to be part of a specified security group in a specified VPC. Those things. It's quite declarative. It's very much self-evident, and this is the cornerstone of a lot of infrastructure as code frameworks on AWS. CloudFormation is, in my case, the OG, the original infrastructure as code framework that I've used and that I've started with. And again, even today, if you use much more, let's say, modern versions of infrastructure as code, a lot of them still depend on CloudFormation. A second favorite one for a lot of people, and myself included, is the wonderful Terraform. Coming from the amazing folks at HashiCorp, Terraform is an infrastructure as code framework that allows you to define your infrastructure through code. In this case, it's not just your pure JSON or YAML. It's something called HCL or HashiCorp language. This is a domain-specific language to HashiCorp, or to Terraform in this case, and it is just wonderful. It is extensible. It is, in my opinion, much more readable than CloudFormation because You can do a lot of fun things. For example, you can read things off a disk, while in CloudFormation, everything has to be self-contained in the template. You can create custom modules that basically give you custom functionality to your piece of code. And also is quite extensible, works with multiple different platforms, cloud vendors, even just different environments, different things, right? I believe with Terraform you can configure things like Cisco switches and stuff like that. So it's not exclusively connected to Amazon Web Services or the cloud in general. Just a wonderful thing, and you know, a lot of people use it, so there's a massive community thriving out there. Moving a bit forward, we have the AWS Cloud Development Kit, which is, I'm in love with AWS Cloud Development Kit. I'm not a developer per se, but I love the fact that you can use the AWS Cloud Development, or CDK, to build your infrastructure through the power of generic programming languages. Now, unlike Terraform and CloudFormation before, this is not declarative per se. This is imperative. You use your, in this case, like TypeScript. You use languages like TypeScript, Python, right? I use Java, JavaScript, Golang, and .NET to describe or actually declare your infrastructure. There's a lot more logic behind all of this, because again, you can use generic programming language skills to do this. So anything from like, you know, having your loops, reading stuff off disks, doing a lot more complex logic and modularity within your code. It is just great because, number one, if you're already quite familiar in a language like Python, you can use those skills to improve your infrastructure code and make it super amazing. You can use testing frameworks. For example, if you write things in JavaScript, you can use the Jest framework to actually run unit tests against your infrastructure code, which is just wonderful because you can test your code before it goes into production. We'll talk about that in a moment as well. So this being said, it's just a neat little thing that kind of gets you to do more, right? And imagine if your company was a Java company, you work a lot of, your projects are written in Java. That means your developers must know Java, right? You have tooling built around Java. You have pipelines built around Java. Why not build your infrastructure through Java? So it is just great. And ultimately, CDK actually converts all of those things into CloudFormation. So it just gives you a really neat way to deploy infrastructure, create infrastructure through a generic programming language, and it will convert it, or it will spit out CloudFormation, which will build stuff at the end at AWS. So it is just great. So one more reasons people use things like CDK and Terraform and CloudFormation is you build your own Lego bricks. Yeah. What does that mean? In the cloud, we like to say we give you all the building blocks, and you build something out of for yourself, right? But what if you want to build your own building block? And this is a fair ask, right? So if you have multiple teams building, let's say, building specific servers, EC2 instances, databases, even complete complex setups with multiple elements on AWS, you can give them a piece of code and say, please make sure every time you're writing your infrastructure, build your infrastructure like this, right? So instead of just providing them with this infrastructure, you can just provide them with a module. Right? Providing, besides just giving them, hey, please make sure to type out your code like this, why not just create a reusable module? You can do that with CDK and Terraform, right? Build, let's say Darko's company has a specific database thing they want to deploy, and I will create a module for that specific way we want to configure databases. So instead of having people make sure that they write the databases exactly the same time as always, we will just have a module which they can import and just activate invoke and have that database be provisioned just the way we always do it. So that is a great way. Again, building custom building blocks for yourself can keep you standardized, can keep you safe, and it can keep you going quite much faster, right? remove all the iterative work you are doing. All right, speaking of iterative work, things that are not fun, but are very important. Let's talk about testing. Testing is a thing you immediately connect to, like, oh, well, I test my code, right? Of course, we have a pipeline and the code goes to unit tests, some integration tests, smoke tests, user acceptance tests, penetration tests, security tests, load tests, all of the fun tests. But in the beginning, I mentioned that infrastructure code is code, and you can treat it like any other code, which is just wonderful. So you can actually test your infrastructure code through, well, tools. So a couple of things you need to think about, a couple of things that you need to focus on when you are testing your infrastructure code, right? With infrastructure code, it is relatively simple to detect a problem early on, because if you deploy a broken piece of code, it will just not run, right? You just deploy it and you just fails because you misconfigured it, or you did not put a proper parameter, proper value. What about those mistakes that are invisible initially? For example, what about if you, let's say, I don't know, forgot to encrypt a bucket, or forgot to specify a specific version of said encryption, or maybe use a wrong database engine. Those things are not necessarily errors in the infrastructure sense. The infrastructure, fine, it doesn't care. But those are errors because you don't want those things to happen. So how do you actually figure those things out? Because when you do things manually, kind of check out the box and you make sure you can look at your code, right? You can just open up your CDK or Terraform code and like, I want to make sure that I've written all of the stuff down, but do you really do that? Nobody does that. So we need some tools, we need some things in place to kind of help us with that. Let me talk about AWS CloudFormation Guard, or CFN Guard. This is a way to write policy as code. In essence, it gives you this deployment safety. It tests your code before it is deployed. Now, it doesn't test it, is it going to be good? Is it going to succeed? Those kind of things. It tests for policy items. If you can see here on screen, maybe I can even draw things. Where's my pen? So if we, not that, come back, thank you. You want to see Darko. There we go. Let's say you want to make sure that all of your S3 buckets are encrypted. That is very important, right? You can actually do that with something like CFN Guard, because CFN Guard enables you to set up specific policies. Like in this case, if you look at the thing below, this is an example of a policy in the bottom part of the screen. I created a single rule, so there's one rule here that basically checks if buckets are using a server-side encryption algorithm. Basically, it checks if encryption exists on that, and is it set to a specific allowed algorithm here that is defined here. This is wonderful because I define a bunch of these rules in these files, and once I run CloudFormation Guard against my template, it will ensure that those things are existent. So what it will do, it will actually go through a template and just like look at it line by line. To be honest, it's going to look at it by resource and check if that resource is according to this policy. So it will check those things. And if it is good, it's going to say pass. If it's not good, it's going to fail you and it's going to tell you what's actually wrong. So this is a pretty important part, and you can extend this. This rule development kit is pretty good. It's extensive. You can define anything that's possible within CloudFormation. So gives you this kind of a safety net that you have actually deployed the things you want. You can have a different team writing these policies and just have them out there, which is just great. All right, moving on. What about if you actually pass all of these things, right? And you're like, yep, all of my code has passed. My policies, my CFN Guard has verified that my CloudFormation code is good. Oh, by the way, this works with CDK as well. All verify that my CDK code is good and my CloudFormation code is good, all that stuff. But how do you know that it's actually like that? How can you verify that in production on your AWS account, this is still the way you want it? There's a wonderful open source tool out there from the amazing folks at Chef called Inspec. Inspec is another, let's say, policy as code tool, but in this case, Inspec doesn't check your template. Inspec checks things. Inspec goes out there to your AWS account and actually looks at things to see, is it actually the way I want it, right? So in this example here, you see like disallowing insecure protocols by testing. This is an operating system thing. This piece of code makes sure that Telnet should not be installed. Simple as that, right? It will go to an instance, check if Telnet is installed, and come back to you with like, yep, it's good. It can also do other things. It doesn't have to be just an instance. It can check like if encryptions are enabled on all buckets. If, I don't know, VPCs have a specific amount of secure subnets, or security groups have no port 22 open to the world. Because Inspec will not just check your code, it will check the real thing provisioned by your code, which gives you an additional sense of safety to kind of know what exists out there in the wild in your AWS account. Okay, now speaking about wild things in your AWS account, how do you get those weird things you've written inside of your CloudFormation template, Terraform template, CDK code? How do you get those things to the cloud? Well, you deploy it, right? Okay, yes, you do. Now, there's a couple of ways to deploy it, and the most common way would be, for example, in CloudFormation, you would write your wonderful template, and then you would go to the CloudFormation console, click a button, create stack, upload the template, set your parameters, and click Start Deployment. But that involves mice, and however much I love a mouse, I would rather just Git push. This is better. No matter which framework you're using, by deploying things with Git push, you get into the whole GitOps thing, right? And this is not a talk about GitOps, but GitOps is just a wonderful way of approaching things. It upholds the principle that Git, or a code repository, is the only source of truth. That means any infrastructure change, any operational change, any application change needs to go through a code repository, right? You cannot manually make a change. You cannot manually create a CloudFormation template or upload a file somewhere. Everything you do needs to be through Git push, right? So this is one of the reasons that, you can Git push a click on a web console, but you can Git push a piece of infrastructure code, which is just, again, wonderful. So once you do a Git push, your thing goes into a pipeline, a CI/CD pipeline. And this enables you to constantly be able to not just deploy your infrastructure relatively fast, but also it will roll back if something goes bad. It will roll back if a test fails. You can keep tests in your pipeline, your CFN guards, or even later on, you can have your Chef Inspec running tests after the things have been deployed. And if things go bad, you can just deploy back, which is just wonderful, right? You can version control the infrastructure. You can do all of those things. So infrastructure as code enables you to not just deploy your application through the means of a Git push, but also deploy your infrastructure changes, and even some operations on it. But now, let's see this thing in action. If you recall, before we started, I did something. And now let's hope it's all good. So if I go back here, something is, you can see things here, right? There's a bunch of stuff happening. We see global demo stack, global ECS demo stack US, and a bunch of outputs. If I come here and I take this thing, copy it like so, switch over to this thing and paste, I have a simple PHP app. What has happened here, if I go here and look at this, in the time it took us to talk, 23 minutes and 50 seconds, I've deployed a globally distributed container cluster with infrastructure as code. So going here, you will see that I have a CDK application. This CDK application deploys my infrastructure across 3 regions: United States, US East 1, EU West 1, and finally AP Southeast 1. With a single command, which I named Let's Go, but it's basically a CDK deploy command. With a single CDK deploy command, I deployed a fully fledged container cluster with 6 services, with a service running on top of 6 Fargate instances, and all behind the load balancer. I spend this wonderful time talking to you instead of going and clicking through a bunch of things and hoping they're all the same. I just repeated a single chunk of code 3 times, right? So if I would go here and lib and this, I just repeated this piece of code 3 times and it launched my cluster. This is one of the powers of infrastructure code. I can do this 10,000 times if I had the limits. It would take me the same effort. That's just wonderful. Spend your time on a good Friday afternoon rather than just like clicking through a bunch of things and hoping you did them all the same. All right, back to the PowerPoint, because that's what we're all here for, right? Okay, I have a minute left. A couple more things. A book. I would recommend this book. If you're getting into infrastructure as code on AWS, the Definitive Guide to AWS Infrastructure Automation by Bradley Campbell is my go-to book. Check it out. It has, most of the book is just code, so great thing to learn CloudFormation, Terraform, and even some CDK. Takeaways. Very important. Get into infrastructure code early on, right? It will help you in the long run. Even if you're running a single EC2 instance, if you're running an S3 bucket, maybe a database, get into it. Start early, start expanding that code, and it's gonna make it so much better as you move along, right? Treat your infrastructure as any other piece of code. Put it in a Git repo. Take it through a pipeline. Test against it. Use the best text editor, which is Vim, of course. Use your best text editor, the tooling, the knowledge you have. And also, use the best tool that fits your needs. In this case, I'm talking about the best framework. CloudFormation, Terraform, CDK, Pulumi, Troposphere, doesn't matter. The one that serves your purpose is the best one. Somebody told me a long time ago, the best programming language is the one you know. With that, thank you very much. I hope you enjoyed this presentation. My name is Darko. Please do let me know if you have any feedback on the social medias. Reach out to me directly via LinkedIn, Twitter, MySpace, Friendster, Carrier Pigeon, whatever. So I really hope you enjoyed this presentation. It's been my pleasure delivering it to you. I always like talking about infrastructure as code, and I wish you have a lovely rest of the day. Bye-bye.
Hi everyone, I am Gunnar Grosch, developer advocate with AWS. I've spent most of my adult life building and operating applications, and over that time, everything has become more and more complex. So thinking about how to make applications more reliable and resilient has really become an important part of everything that we do. So today I want to talk about how we can improve resilience and performance with controlled chaos engineering. And you might be wondering what chaos engineering is, or maybe you're already an expert and instead wondering how to use this. So I think I have answers for all of you. So let's get into it. First, a quick look at the agenda of this session. So I want to start off by talking about distributed systems and why chaos engineering has emerged as this great solution to help deal with the complexity and the uncertainty of these complex systems. So I'm going to go through the current challenges that customers face when starting their chaos engineering journey and explain why they've asked us to build a managed chaos engineering service for them. And I will, of course, take a look at all of the constructs supported by the service, and we'll finish with a few demos so you can see it in action. So let's get started. While the benefits of distributed systems are undeniable and have revolutionized IT, they do have some challenges. And challenges with distributed systems involve latency, scalability, reliability, resilience, concurrency, designing APIs, and so on and so on. And as systems grow larger and more distributed, what's often only a theoretical edge case can sometimes turn into real occurrences. And while most people understand that distributed systems are complex, it's a common mistake to think that this complexity only applies to applications that have hundreds or thousands of microservices. And that, of course, isn't the case. In fact, even simple applications are complex. Take, for example, a simple client-server communication. There are a lot of steps involved to successfully complete just a single round trip. So the client puts a message onto the network delivers the message to the server validates the message, the server updates its state, the server puts reply onto the network delivers reply to the client validates the reply, and the client updates its state. It is mind-boggling to consider all of the permutations of failure that can happen in this very simple distributed system, especially over multiple requests. So imagine what it looks like for thousands or even millions of requests. And a traditional way of tackling this has been testing. But as distributed systems have grown more complex, testing has really reached its limits. And often we only implement tests after outages have happened in production. And of course, by then, it's already too late. So testing is, of course, mandatory, and you shouldn't stop doing testing, but it doesn't apply well for distributed systems. And it often doesn't address the complexity of our production environments. So test things in isolation, and testing really only verifies the known conditions. So a test answers questions like, is it what we're expecting, or is the result of that function X? So what about all of these random failures and other weird errors that happen on networks like the internet? And what about configuration limits and drifts? What about all of the unknown? How can you test something that you don't know yet? And some things are just really hard to test. For example, in a system where instances start and stop dynamically, what happens if any of those instances run out of disk space? I'm pretty sure a vast majority of the audience have faced disk space failure in some form or another. And debugging apps that run out of disk space, well, it usually looks something like this. And that's a really common issue that happens often when there's no log rotation. And to make things more complicated, you can get a no space left on device error when there's still plenty of space left on the device. For example, when the file system have run out of inodes because too many files have been created. And the problem with disk space failure is that it's localized and isn't something you can catch during testing. So what happens when you have a disk space failure? Well, if your instance does not have space left to write logs, most of the time it fails fast. And that's a real issue because by doing so, it creates a backhole. Because it fails fast, it fools the load balancer into thinking the instance is free to receive more requests, which in turn fail. So if we could have caught that earlier, we could have made improvements before they become outages. Improvements such as log rotation or using a centralized log service, or monitoring of disk space, and then have some alarms when only X amount of disk space is left. Then that would give us some time to act before the outage. And that's just naming a few. And luckily, there is a practice that helps with this kind of unknowns. And it is, as you probably guessed by the name of this session, chaos engineering. So chaos engineering is the process of stressing an application in testing or production environments by creating these disruptive events, such as server outages or API throttling, then observing how the system responds and implementing our improvements. And we do that to prove or disprove our assumptions about our system's capability to handle these disruptive events. But rather than to let those events happen in the middle of the night or during the weekend, we can create them in a controlled environment and during working hours. And I think it's important to note that chaos engineering is not just about improving the resilience of your system, but also its performance, to uncover hidden issues, expose monitoring, observability, and alarm blind spots, and more, like improving recovery time, improve the operational skills, the culture, and so on. And it's also very important to understand that chaos engineering is not about breaking things randomly without a purpose. Chaos engineering is about breaking things, but in a controlled environment through these well-planned experiments in order to build confidence in your application and the tools you're using to withstand turbulent conditions. And to do that, you have to follow this well-defined scientific method that will take you from understanding the steady state of the system you're dealing with, to articulating an hypothesis, to running an experiment, often using fault injection, then verifying the results, and finally learning from your experiments in order to improve the system. Improvements such as the resilience to failure, its performance, the monitoring, the alarms, the operations, the overall system. And however, while chaos engineering is a really great to have option in our toolbox, many of our customers have told us that they feel it's hard to get started with. Hard because currently you have to stitch together different tools, some scripts, libraries to be able to cover the full spectrum of faults that you can inject in a system. The infrastructure, the network, the applications, each have different tools to do the job, whether it's a library or an agent. And customers often don't want to install extra things in their applications. More things to install equals more complexity. And it's also difficult to ensure a safe environment in which to inject faults. Ideally, you want your tools to automatically stop and roll back if any alarms are setting off. And you also want these to integrate nicely with the monitoring solution. And finally, some failures are simply really hard to reproduce. So it's important to realize that outages rarely happen because of one single failure. It's often a combination of small failures happening at the same time or in sequence. And that, well, it's just hard to reproduce. So I want to introduce you to our new fully managed chaos engineering service, AWS Fault Injection Simulator. And it is an easy to get started service which lets you reproduce real world failures, whether they are simple like stopping an instance or more complex like throttling APIs. And AWS FIS fully embraces the idea of safeguards, which is a way to monitor the blast radius of the experiment and then to stop it automatically if alarms are setting off. And getting started with the service is very easy, and this is something we've put a lot of effort into since our customers have repeatedly told us that it's hard to get started with chaos engineering. So you can use the console to get familiar with the service, try things out, and then you can use the CLI to take advantage of the templates and integrate the service with CI/CD pipelines, for instance. And the templates, they are JSON or YAML files that you can share within your team, you can version control them, and benefit from all of the best practices associated with code reviews. And you can run your experiments either in sequence or in parallel. And sequences are used to test the impact of gradual degradation, like sequence of actions to gradually increase latency. And parallel experiments are to test the impact of multiple concurrent issues, which, as you probably know, is often how real-world outages happen. And supported services are EC2, RDS, ECS, and EKS, and more will follow. So you can create complex conditions that span across a large set of AWS services. And just to hit the nail on the head here, these faults are really happening at the service control plane level. So an instance is actually being terminated, memory is actually being utilized, APIs are actually being throttled. It's not faking it with any type of metric manipulation. So you really have to use extra caution when using AWS FIS. Safeguards, they act as the automated stop button, a way to monitor the blast radius of the experiment and make sure that it is contained. And that failures that are created with the experiment are rolled back if alarms go off. And we have IAM controls that can be used to control what fault types can be used and what resources can be affected. And you can, for instance, use tag-based policies. So only instances with the tag environment test or staging can be affected. And to use the service, you only need to understand these 4 components: actions, targets, experiment templates, and experiments. So let's take a look at each, what they do, and how to define them. Actions are the fault injection actions executed during an experiment. And actions include the fault type, the duration, the targeted resources, timing relative to any other actions, and fault-specific parameters, such as the rollback behavior. Targets define one or more AWS resources on which to carry out an action, and you define targets when you create an experiment template. And you can use the same target for multiple actions within your experiment template. And they include the resource type, the resources themselves, and the selection mode, if you want to select all, or a random selection, or a percentage. And the experiment template, they define an experiment and are used when you start an experiment. And the experiment template then includes the actions we talked about, the targets that I mentioned, and the stop condition alarms that we set up, and the IAM role which you use to run the experiment, and also some description and tags. And as I mentioned earlier, you can run simple experiments like the one on the left right now, sequential and with specific targets. Or you can create more complex experiments running in a mix of sequence and parallel execution and use very advanced filtering for your targets. And for both, we really suggest that you use alarms. So no matter if it's in production or in test environments, it's the best way to really benefit the full power of service and helps you find these monitoring blind spots as well. And then finally, we have experiments, and they are simply a snapshot of the experiment template when it was first launched. So think of it as your history of experiment execution, and it adds some additional information on top of the snapshot, like the creation and the start time, the status, the execution ID, and so on. And here are some of the faults that AWS FIS supports today. And as I mentioned, we're going to keep adding new actions to AWS FIS going forward as well. So with that in mind about AWS FIS and chaos engineering, let's talk a bit about use cases. So today we're seeing customers use chaos engineering quite a lot, actually, and that usage is growing. And we've also seen that a few clear use cases have emerged. And the perhaps most common way of doing chaos engineering experiments is by creating the one-off experiments. And this is when you create experiments by, for instance, looking at previous outages and events for your system. Or you can identify the services that have the biggest impact on your end users or your customers if those services go down or don't function correctly, and then create experiments for those. Or maybe you've built a new feature, added a new service, or just made changes to the code or architecture, and you can create experiments to verify that the system works as intended. And we see companies doing this in different ways. Some have dedicated chaos engineers creating and running the experiments. For others, it's part of the SRE's responsibility. Or as we partly do at AWS, chaos engineering is done by the engineering teams themselves on their services. The second common use case is to use chaos engineering as part of your game days. And the game day is the process of rehearsing ahead of an event by creating the anticipated conditions and then observing how effectively the team and the system respond. And an event could be an unusually high traffic day, a new launch, a failure, or something else. And you can use chaos engineering experiments to run the game day by creating the event conditions and monitoring the performance of your team and your system. And the third common use case is automated experiments. Automation helps us cover a larger set of experiments than we can cover manually, and automated experiments verifies our assumptions over time as unknown parts of the system are changed. And automation of chaos engineering experiments can be done in several ways. You can schedule your experiments to run on a recurring schedule. The experiments can be triggered by events in your system, or perhaps the most sought after, including chaos engineering experiments as part of your continuous delivery pipelines. So those are three common use cases for chaos engineering. So with that, let's move into the demo section. So first, I want to show a very simple example of when we simply stop EC2 instances, create an experiment to see what happens with our system if an instance is stopped. So this is the AWS Fault Injection Simulator console. So let's create a new experiment template. I'll add a description, give it a name. I then select the IAM role that is allowed to run this experiment towards my targets. Next step is to add the actions, and we'll give that a name, each action, and we then select the action type from our list of actions. And in this case, we're using EC2 stop instances. And we can then choose to add a timing when these instances should be started again. So since this is a demo, I'll just add 1 minute and save this action. Now we could add additional actions, or in this case, let's just move on to adding targets. And I'm going to specify one specific EC2 instance in this case. So let's add that one and save. And now I've mentioned several times that stop conditions is something that we should use. This is a demo, so I'm skipping stop conditions for now. So let's just create this experiment template. Since I don't have a stop condition, I need to verify that I really want to create this. And now with that, let's have a look in the EC2 console. This is the EC2 instance that I selected as a target. It's running. So now let's start our experiment. Start and confirm. And now that experiment is starting. As I also mentioned before, these actions are really happening on our resources. Now, when this is running, well, my EC2 instance is then stopped. So checking in the console, we can see that it is stopping. So these actions are really performed on our resources. And now, as soon as this experiment is done, it was a quick one, 1 minute. So now when it's completed, now it should then start my instance again. And as we can see, it's now running again, and it is in the initializing phase. So that was the first very quick example of using the AWS console to create our experiment and then run that. So let's have a look at another one. In this case, we're going to use stop conditions. So back to the AWS FIS console. Let's update our experiment template. We still have our actions, the stop instances actions, and we have a target specific instance that is running. And now let's have a look in the CloudWatch console to see. I have an alarm set up in CloudWatch, and it is in the OK state right now, so it's not alerting. So let's add that as a stop condition. And it means that if this alarm is triggered, it will automatically stop my experiment. So let's give that a try. Let's start this experiment now. Confirm that I want to start it. And now this is initializing. Let's have a look. All right, so it is running the experiment. meaning that it should now stop my EC2 instance. All right, that is stopping. And now my alarm isn't setting off because that doesn't really affect by the EC2 instance. So let's use the AWS CLI to set the alarm state manually. So we can set my alarm to the alarm state, meaning that it will go into an alarm state. So let me just add the region as well. And then here we go. Now switching back to the console, we can see that the alarm has gone into the alarm state. And this is for demo purposes to see what actually happens. So now, as soon as that goes into alarm state, it actually stops my experiment. And as I mentioned before, when an experiment is stopped by a stop condition, it should roll back on the actions that support that. So in this case, it should then start the instance again, which is exactly what happened. So that was a second example of how we can use stop condition and how we should use stop conditions. In this case, it was a simple alarm. We could add up multiple alarms onto one single experiment as well to make sure that if something goes wrong, it will automatically stop that experiment. So next, let's have a look at how to use filters and tags when we create our experiments. And in this case, I'm going to use a bunch of EC2 instances that are spread out across different availability zones. And they all have a tag for being a FIS target. And now we're going to use an experiment template in JSON format instead. So the resource type is EC2 instance. I've added a tag for FIS target equals true. I set a filter, first off, that the EC2 instance is in the running state. And secondly, I've added a filter for the availability zone. So it should only affect instances in that zone. And I'm going to select all of the instances that are matching towards that filter. As an action, we're using the same one. So we use EC2 stop instances. I've set it to start again after 1 minute in this case. And the action is pointing towards the target, my targets that we defined just above in the template. I have a stop condition in place as well, of course, pointing to an alarm. And that is my FIS demo alarm. And finally, we have the IAM role that allows us to run the experiment towards our targets. All right, so with that JSON file in place, I can now create an experiment template using the AWS CLI. So AWS FIS create experiment template pointing to my JSON file. That is created, and in the output, I get an ID of my experiment template. So just copying that. And now, still using the CLI, I can run AWS FIS start experiment towards my experiment template that I just created. So now I have a running experiment, actually without using the AWS console, instead by using the AWS CLI. So it is running. Checking the EC2 console, we can see that instances in that availability zone that I defined are now stopping, exactly as we wanted. And in this case, it is quickly completed as it was a short demo experiment. And now as soon as that is completed, it should then start the instances again. And they are in the running state. And this was a quick example to, for instance, test what happens if instances in one availability zones goes down. Will that affect my system or my end users? And in this case, we used filtering and tagging to then set up that experiment template. So for these demos, we used simple, easy to stop instance actions, but you could easily, of course, substitute those for any of the fault injection items that I showed earlier and that you see on screen right now. So if you want to get started using AWS Fault Injection Simulator, you can look at the AWS FIS site on the AWS website. Have a look at the AWS FIS documentation, contains a lot of helpful information. And on AWS samples on GitHub, we have a lot of different examples that you can use to get started with, also setting up simple demo environments to run your experiments against. And with that, I want to thank you all for watching. We've looked at how to improve resilience with controlled chaos engineering using AWS Fault Injection Simulator. If you have any questions or comments, do reach out on Twitter at Gunnar Grosch, as shown on screen, or on LinkedIn. I am happy to connect. And with that, thank you for watching.
We are one of Deutsche Telekom's brands in Hungary. We are Deutsche Telekom IT Solutions. Welcome and sign in. Let's see who we are and what we do. As one of the largest IT employers in Hungary, we have campuses in 4 cities. Would you like to work from home too? You will have the opportunity to do so with us. Although 29 nationalities work with us, we always find a common language. And you will have the opportunity to get the most out of yourself in the position that works best for you. Having a supporting, tight community in our company is essential for us, and we are building this community offline and online with cooking, book, or esport clubs, and our online year-end event.
I would like to remind you that these are the values that connect us as colleagues and as people. This is what we signed up for.
Sustainability is of great importance for us because we believe that only sustainable development is worth pursuing. Thousands of training opportunities support our colleagues in their professional growth. Click, apply, and open a new page with Deutsche Telekom IT Solutions.
Okay, we're live from the funny farm.
My name is Tom Erik Støver.
And I'm Kim Bredse.
Where to begin? You usually do the story.
Okay, I'll try. Me and Tom Erik, we've known each other since high school, and we both have the same kind of interest in IT, so we worked in IT together for a long time.
Kim told me at some point he wanted to go to this evening school for agriculture, and I said, well, I want to go too.
That led up to our starting to work together on the bees and the IoT, and now we're basically working after hours with the BIoT solution.
We do a lot of stuff together.
Yeah, we do.
As a society, we've moved so far apart, especially kind of bridging the gap between where the food is produced and the person is actually eating the food. Honeybees pollinate around 1/4 of all agricultural crop. With BIoT, I think we can make that connection again.
Welcome to my farm. It's a Norwegian farm. We're located about 45 minutes from Oslo.
What are you growing over there? Oats?
Oats, yes.
So we have some sheep and pigs.
And here are some of the beehives.
In Norway, at least, if you're a beekeeper full-time, you have 250 beehives. If we're going to do the job properly, we're going to inspect everyone once a week during the high season.
And we have to open each hive, and it really disturbs the bees. We wanted to do it a better way.
We started looking into how can we do that checking in with the bees without actually opening up the beehive, meaning putting sensors inside, camera, microphone. We measure the weight of the whole hive, temperature, relative humidity, CO2, infrared spectrum, and volatile organic compounds. We use all the data that we collect to have the beehive tell us when it needs something to be done with it. The natural next step for us was, if the beehive can tell us when something needs to be done, can we also make the beehive do that thing itself?
During the winter, the bee colony gets kind of small, and then as the spring and summer comes, it gets bigger and bigger, so it needs more space.
So in traditional beekeeping, you would have to add space incrementally throughout the season. In our vision, we would have all the boxes there, but we would have mechanisms to make that space available to the bees. We have these small, inexpensive computers called Raspberry Pi installed in each hive. They receive data from all of the different sensors in the hive. Then we use AWS Greengrass to make all these pieces work together and connect to the cloud in an efficient way. Greengrass also allows us to process the data and use machine learning locally in each hive.
When the beehive can do the operations itself with the cloud at the edge, we don't need to transfer as much data, and we can just make the beehive very smart, so it's cool. I think BIoT is about connecting the people to the beehive. Machine learning, it's the reason why we can do this. You can experience bees while in the city, basically. You can own a beehive, and the beehive can be out in the countryside.
The disconnect in something so essential to life is, it's a worry that's been growing in me for many years.
With the BIoT solutions, if you have some space, you can have a beehive, and the beehive can take care of itself. That potential in technology is really exciting.
Hi, my name is Csaba Szegedi, and I work at Deutsche Telekom IT Solutions as an AWS solution architect. Previously, I worked as a developer for more than 10 years. I started my cloud career like 6 years ago, worked as solution architect, and I also work as an authorized AWS instructor since more than 3 years, delivering architecting on AWS and developing on AWS classes. Our today's topic is about managing private EKS Kubernetes clusters on AWS with a well-usable local IDE. So to go through this whole process, let's first check what really Elastic Kubernetes Services is and what Kubernetes is. So Kubernetes, first of all, is an orchestration open source platform for managing containerized solutions. It consists of worker nodes and it consists of control plane. The control plane has several components and it manages the worker nodes. It's an interesting fact that the name Kubernetes originates from a Greek word, which is helmsman or pilot. You could also meet Kubernetes on the internet with the abbreviation, which is K8S or KATES, resulting from the Kubernetes words. The beginning letter is K, the last one is S, and the number of letters between these two characters is 8, so from this you have the KATES abbreviation. So portable, extensible, open source platform for managing containerized workloads and services. Now, when you deploy a Kubernetes service on your own servers, usually it takes some cumbersome manual work to configure the whole cluster. With LSD Kubernetes services, you have a managed service which can set up Kubernetes for you. It will install, operate, and maintain your Kubernetes control plane and nodes. EKS creates the cluster over multiple availability zones. This gives you automatically high availability and will scale control plane instances based on load, detects and replace unhealthy control plane instances, and provides automated version updates. Patching also is supported. So the whole manual work is instead managed by AWS, and reducing the creation of Kubernetes cluster creation to a couple of tens of minutes. Now I mentioned the IDE, which is used to access these Kubernetes APIs, Kubernetes control planes. The IDE, which I want to show you, is called Lens. It's a really easy, usable tool which removes the complexity of using kubectl tools and providing you UI access to your clusters. This tool will provide you a dashboard where you can see logs, statistics, errors, warnings about your cluster, and you can manage nodes, namespaces, pods, which run in your cluster. Okay, so this is a good way, and developers usually get used to this tool easily and would like to use this tool on their EKS clusters also. Okay, now there are several ways to set up this EKS cluster. First is, and the default setting is that you can access this cluster from the internet. So the Kubernetes API will receive an endpoint which is publicly accessible from the internet, and using some kubectl command from your local developer machine, if you have the necessary rights, AWS rights, then you can access these clusters. So this is these default settings using identity and access management, which is a central service of AWS, providing you authorization of users and temporary roles into your account. Now you can map these users and roles to Kubernetes roles used with this RBAC service, and then you can provide for your AWS users Kubernetes roles, Kubernetes users. The whole process is like the following. The kubectl will call the Kubernetes API, will pass the credentials from AWS. The Kubernetes will go to the IAM and will verify the credentials. After the credentials are verified and are valid, Kubernetes will go and do the authorization, the API, and return back to the kubectl if the action was allowed or denied. So this solution is valid for both public and also for private access created with AWS. So actually, there are three ways to provide the access: the public, the private, and you can provide both public and private access. When you create private access, then actually your Kubernetes will run inside of a VPC. So your nodes, the API servers, will stay in your VPC. And the API server won't be accessible from the internet, just from within your VPC or from within a network which is connected with your VPC virtual private cloud. Okay, now how can we access these private EKS clusters? There are several ways. One is connecting really your on-prem server with the VPC network. Two solutions are available, general solutions. One is the Direct Connect service, which is a private connection between your on-prem and corporate VPC, or you can create VPN connections. And these connections are going through the internet, but encrypted. Using both solutions, then you can access your Kubernetes API, and with this, your containers running inside of the cluster. Okay, so we covered with this one aspect, but there are use cases when there are some developers or users who are not working inside of your company. They don't have access to the corporate network. They're blocked by firewall, security group, everything secured from AWS side. Users don't have access. In these cases, generally, we provide a bastion host to these users. Okay? The bastion host could be either be an SSH or an RDP connection, for example. Now, in many cases, in majority of the cases, the SSH RDP is not allowed. These ports protocols are blocked. Okay, but then how to solve this problem? The solution provided by AWS, it's called Session Manager, or it's a service from AWS Systems Manager. This solution will provide you with an agent which can be installed in your EC2 instance, and then you can connect to the EC2 instance via this agent. This agent will create a tunnel from either your machine or from the management console, and when you log in, you receive a terminal access, and using kubectl commands, you will be able to access the Kubernetes API. Now, the permission for this instance is provided by the instance profile, or the IAM role, which is attached to the EC2 instance. So using this IAM role and the RBAC, you will be able to limit access to the cluster on namespace level also, for example. Okay, so one option to access this via Session Manager, your instance, is using the management console. Let me just quickly show you this option. I'm logged into the management console, and let me just find my mouse. Yeah, you see a list of instances. This is my bastion host. The other two instances are the nodes from the EKS clusters. So started automatically, managed by the service itself. So I simply select my bastion host. I hit the connect button. Switch to the Session Manager tab here and hit connect. In this case, the connection uses the Systems Manager Session Manager, and I'm already on the machine and can call kubectl get service, for example. Okay, you see, I am connected with this cluster. I just navigate there to the cluster itself. The cluster itself is called Lens Test. And yeah, you can see that I have two node groups running. You can see the workload. If you configure that one in the management console, you will be able to see also important information from your cluster in this page also. Okay, and some configuration related to the VPC is available in this last step. Okay. I was connected to this cluster using the session manager. Okay, so this was one option. The other option is to use the session manager plugin, and you can use that when you want to log in to your instance from your own developer machine. In this case, the tunnel will be built up between your plugin, session manager plugin, and the SSM agent. And then on your machine, you will be able to execute these commands. So you will be on the Bastion host, but the commands are executed on your machine in a terminal window. I will demonstrate that one also, just switching to a correct command window. Okay, I have my IAM user set up with AWS configure. I have switched to the relevant profile. I checked if I'm authenticated with that user. It's correct. So what I need to use now, I have a shortcut here with the session manager start session, but you will see the command immediately. What I will need here is the ID of my instance. Okay, so I quickly grab that instance ID, which is this one. I start the session, AWS SSM start session, and the target instance ID. I'm in the session, kubectl get service. Okay, and let's quickly create a namespace, kubectl create namespace test1. Okay, namespace created. I just log in here, and this is the management console session, and see the namespaces. So you see that it's created kubectl get namespace. Okay, I have a test1 namespace created. Okay, so we are on the local developer machine. We have connected to our cluster. Okay, but we were talking about a nice IDE, a UI on how can we connect with that. Okay, we need to work a bit to provide this whole connection. We use this session manager plugin. We use the SSM agent, but the session manager plugin is not used to start the session or not used in the common way. It's used to start a port forwarding session. So the session manager plugin will listen for a connection, for a localhost connection, which can be forwarded via the tunnel to the SSM agent. Now, okay, this command is forwarded to the instance itself, but we need something which is running on that instance to be able to be forwarded to that. Okay, so for that, we will start a kubectl proxy, and via this proxy, we will connect to the cluster itself. This kubectl proxy is kubectl proxy needs that you configure and set up your kubectl config to the relevant server. So what we already have, so I'm in the management console. Let's call the kubectl config view command. See, I have the cluster already configured. This is the name of the cluster to which I'm connecting. So let's just double check here if the endpoint is the same. Yeah, it's the same cluster. It's configured. the correct context is set. So I just called kubectl proxy. Okay, my kubectl proxy is listening. This part is set up correctly. I need to start the port forwarding now. Okay, my proxy is listening on port 8001. So let's remember that one. I just move over to the command window and I use session manager port forwarding. I need the instance ID. So let's use that one from the previous one. My command is prepared with 2 more arguments. So let's use first. Oh, yeah, sorry. I'm still inside of the session. Exit. Yes. So once more, session manager port forwarding local command. From me, you will see the whole command immediately. Instance ID. Okay, so local port is 80 and the remote port is 8001. The command was AWS SSM start session target. Until this point is the same as previously. But we have to use the document, the session manager document, which is called AWS start port forwarding session with the incoming parameters, port number, remote port and local port. Okay, so I'm listening for the connection. This is the proxy is also listening for the connection. I just need one more command window here. This one, okay, I'm with the correct user. Let's just see the local config kubectl view. Okay, the server is set. So if I call the AWS update kubeconfig command, which is like the following. So AWS EKS update kubeconfig name of the cluster. This will update my cluster. You see, this is how it's configured. The whole server name now is changed, but this way, if I call from my local machine kubectl get service, the connection won't be made, so I cannot connect to the server. Okay, I need to go to my notepad where I have the config opened. Just see if I can move this window. Okay, so the same configuration is here, and I just change this to 127.0.0.1. Go to the local host. Okay, so let's see once more. You see, we are now connected via the session manager plugin, port forwarding, and kubectl proxy to a private cluster running in AWS. Okay, let's just call the kubectl get namespaces to see if we have already the namespace. We have that one, kubectl create namespace test2. Okay, let's just double check it, maybe from the management console. Okay. I just start the EC2 and connect for via another session. Okay, kubectl get namespaces, one missing. Okay, both namespaces are created. Okay, and then finally, for what we came, can we connect with Lens? Yeah, let's just start the Lens. Okay, Lens is starting. I will move immediately to the other window. In the Lens, it's possible to use the contexts which are available in the kubectl config. So yeah, this is the Lens UI. No cluster is connected yet. I open my catalog, I browse for the clusters, and I can see automatically from my kubeconfig file that I have a cluster which is prepared. So let's just connect to that. It takes a couple of seconds, but it's connected. I can see a whole bunch of information about my cluster. So the same node groups, which I could also see on AWS, workloads, configuration, pods, if we have started pods. But let's just check the namespaces. Yeah, I can see these two namespaces created. So let's just do a test here too. Let's create a third namespace, which is active, and we double check it from here if it's visible. Okay, so all three namespaces were created. These are the solutions which I tested and working, available for accessing your private Elastic Kubernetes services in AWS only via this session manager. So this is all what I wanted to show you for today. Thank you for your attention and waiting for questions.
Hi everyone, my name is Karol. Welcome to my presentation. I will be talking about how to securely authenticate your GitLab CI/CD pipelines against AWS. Few words about myself. I'm working as a lead architect at Deutsche Telekom IT Solutions Slovakia, which used to be known previously as T-Systems Slovakia. I like all cloud, mostly public cloud and AWS. I like automating and securing stuff. My contact details here. I will be happy if you add me on LinkedIn. So let's get quickly into it. What was the actual problem we were trying to solve? So we have GitLab on one side, GitLab containing our code, and we have AWS on the other side. So the question is how to move code and build how to build code and move the deliverables to AWS. So going one level deeper, we have the actual GitLab instance itself on the left side. Within the GitLab instance, we have a repository or a project in the GitLab terminology. And within that project, we usually have a GitLab CI YAML file, which defines the actual steps of the CI/CD pipeline. So what should happen at which stages and so on. On the other side, we have AWS Cloud. Within the cloud, we have naturally an AWS account where we want to deploy our servers, our databases, and all sorts of other resources. So how to connect these two worlds? Before going any further, let's do some recap on some terminology. So we have AWS account, which is a container for the resources, and it isolates your resources from the rest of the AWS world. And AWS recommends to use multiple AWS accounts for your environment so that you scale the environment better. And usually what then AWS accounts refers to is a stage within an application. So every application and every stage in the software development lifecycle for the application means one AWS account. So if you have an application and you have 4 environments and you have, let's say, 3 applications, it's 3 times 4, so it's 12 accounts, just like that. How to achieve that? Let's say more practically, AWS provides a product or service called AWS Organizations, which allows you to create groups of accounts, organize them, and apply certain policies to those groups. So how does it look like in the web console of AWS? So we have a root sort of organizational unit, or the root of the organization. Then we have an applications organizational unit, and under that we have all of the accounts, then further grouped into the production and SDLC and some other organizational units. So you can define multiple OUs. You can group your accounts in whichever way you want, and so on. So coming next is back to the problem. So how to solve it? Looking at the documentation from GitLab itself, so they recommend to use AWS security keys to connect to your AWS instance. So by security keys, what is meant are AWS Access Key ID and AWS Secret Access Key in terms of authentication. So, okay, let's do that. Let's go to our AWS account and let's create an IAM user. And for that IAM user, let's create the combination of Access Key ID and Secret Access Key so that the user can deploy the servers, the databases, and all other sorts of resources. So let's do it for 1 account. Let's do it for 2 accounts, 3 accounts, and let's do it for all accounts we have within our AWS organization. Same goes for GitLab. We have a repository containing the credentials of the user. But of course, we have our application has multiple environments, so we need to publish the credentials for all of the environments. Some of them are protected. Most of them should be masked. So different configurations. One small detour about environments in GitLab. So what it does is it's a way how to limit the scope of a CI/CD variable to a specific environment, and you can refer to those variables within the GitLab CI file. So we can do it for 1 repository or 2 repositories, and basically we need to do it for all of the repositories for all of our applications. So the number quickly grows. So when I started to deal with this topic of proper authentication of CI/CD pipelines, I first had to look at our environment. So sort of an audit. I found all sorts of things. I found users with very old keys, so they were not rotated for a long time. I found users with administrator access. I found deployment roles which had trust relationship towards 4 different users in 4 different accounts. So nobody knew why was it like that, or what is the purpose of these roles in terms of deployment. I saw people copying their short-term AWS SSO credentials to their so copying and pasting their credentials to GitLab and doing so every morning or every time they wanted to deploy something from GitLab to AWS, and I could continue. So again, before going any further, let's do some recap on the basics. So which kind of IAM entities do we know in AWS? So first we have an IAM user, which can be used for creating requests or sending requests to AWS services using API or CLI. So something we could use for deploying resources to AWS. And the user needs to have up to 2 access keys that can be used. On the other hand, we have an IAM role, which is used somewhat differently. The role is assumable by a user, and it doesn't have any permanent credentials. So what does it mean? It has only temporary credentials, or when the user assumes a role, the service called STS, Security Token Service, returns in response a set of temporary credentials. The benefit of this is that they are temporary, so they expire after a set period of time. So a concept which we can happily use in our challenge or in our task. So how does it look like in AWS? And this can obviously also work cross-account. So we have an IAM user with certain permissions and a certain set of credentials. So AWS Access Key ID and AWS Secret Access Key. In a different account, we have a role, which also has certain permissions and certain trust relationship. So this role has to trust the user, and the user has to have permissions to assume the role. So the user calls the STS assume role API call towards this role, and the STS service then returns a set of temporary credentials. And you can see they are temporary because of this little icon of watch at the bottom right corner. So this is something that we could happily use. How does it look like on the GitLab side? So GitLab offers rich set of API calls which we can use. More specifically for our use case, we are looking for programmatic ways how to manage project level variables or just variables for projects. So if we have a deeper look, we can see that we can create variables, update variables, and we can use also, we can set properties like protected, masked, we can scope the variables to different environments. Sounds good. There are also libraries which make the job for you easier, so you can they can serve as a wrapper around the actual GitLab API. So the solution we have come up with, or which we have created, is called CI/CD Authenticator. In reality, it's a Python script which takes as a parameter a mapping file. So it's a YAML file, which contains a couple of sections. So we have sources, we have destinations, and we have mappings. I will talk more about the file a bit later. So we have the Python script, we have the mapping file, and within the same repository, we also have CI/CD variables containing a GitLab token, which is used for communication with the GitLab API. And the variables also include a set of credentials for an AWS user. So this AWS user, IAM user, lives in a central automation AWS account. It has the credentials which are stored here rather statically. And what this IAM user does, it assumes a role in one of the application accounts. In return, the user gets a set of temporary credentials, and then the script publishes those credentials as CI/CD variables for the repository related to the application. We call it application number 1. So the script goes through the mapping file, and based on the mapping entries, it goes through the accounts, assumes the role, gets the temporary credentials, and publishes them to the corresponding repository of the corresponding application. And this happens at the top of every hour, meaning that at the top of every hour, our developers or the repositories used by the applications get a set of fresh credentials every hour. So what happens then with the old credentials, or what happens if the pipeline is running and the credentials are refreshed? The previous credentials are still valid because we use the maximum validity of 12 hours. So the previous set of credentials is still valid. So how does it look like on the AWS side, or more detailed view on the AWS topics? Before we go there, what I also want to mention that we not only rotate the credentials of the deployment roles, we also create the deployment roles for our developers, for our projects within the actual bigger project. So for that, we have a Terraform repository, or a GitLab repository containing a Terraform project, which uses credentials of another user. We call it the management user, which assumes a management role, which is deployed by a CloudFormation stack set, ensuring that this role is present in each and every AWS account in our organization. So this repository is using the credentials of this user to assume the management role, to actually create a deployment role. Then this deployment role is mentioned in a mapping file within the CI/CD authenticator repository, and the credentials for this role are then automatically published for the corresponding repository of the corresponding application according to the mapping file. And in the end, the pipeline in this application repository can then deploy resources in the target application AWS account. And this happens completely transparently. So once the mappings are set up, once the roles exist, this runs by itself completely automatically every hour. And from that point on, the corresponding developers working on the application do not really have to care about their credentials anymore, which makes their lives really, really easier. On top of that, we have service control policies, which are also part of the AWS organizations, saying that these users, they are quite powerful, but they can only assume certain roles, which are named in certain way. And also these roles are then only assumable, so they have trust relationships only towards these specific users. So how does the mapping file look like? Like I mentioned, it has 3 sections. So we have sources, we have destinations, and we have the actual mappings. So coming back to the sources, in general, we use a YAML feature called anchors. So this is an anchor you define, and then you can refer to that anchor and refer to the values under this anchor later in the file. So for each application and environment, let's call it application number 1, we have the type of the application, and we have the role ARN, which is created in the Terraform repository, which I mentioned previously. Then we have destinations. So for the application 1, we have a GitLab repository with a certain project ID, which is then used later by the Python script. And then we have finally the mappings, where we refer back to the anchors which we have defined previously, and we publish the credentials of the role to a specific we scope the credentials to a specific environment within GitLab. So this concept of anchors, it makes the file quite easy to read instead of just cryptic values and IDs and ARNs and so on. So if we want to create another, let's say, environment for, or if the application has multiple environments and we want to create a new one, so we just create another one like this. We name it, let's say, production. Obviously, it will be sitting in a different account, and maybe it will have different name. The repository stays the same for the application number 1, and we need to modify the mapping a little bit. So we refer to the anchor we have defined previously, and we publish the credentials for the production role to a different environment in the GitLab project for this application. And this is how it looks like in the GitLab UI. So this is the output of the job, which is triggered automatically every hour. So it goes through the mapping file, it assumes the roles and publishes the credentials for the specific or to the specific project ID, and it scopes those credentials to specific environments. And this happens, like I mentioned, every hour. Some gotchas and lessons learned. So pagination, if you look at CI/CD variables within the GitLab user interface, so the web interface, you see all of the variables on one page. If you do the same programmatically using GitLab API, it returns by default only 20 variables. So the first 20 variables, which makes the processing of this in a programmatic way a bit difficult. So I had to use the parameter for let's say more results per one page. API throttling. So sometimes there is a lot of API activity within the GitLab instance, and from time to time we can see errors 4 to 9 returned from GitLab. So some retries would need to be implemented as a fix. Role chaining. That's actually a concept where you assume one role, and then from that role you assume another role. So this happens for one of our special applications. And if you assume a role twice, or if you assume another role from already assumed role, the maximum length of the session is 1 hour instead of 12 hours for just a single role assumption. Fortunately, our deployments took less than 1 hour, so this is not yet a problem for us. Feature improvements, like I mentioned, it would be good to implement some retries to fix this 4 to 9 error. The deployment roles could be deployed, let's say, more automatically. There are projects like TerraGrant, which could do some automation for you in terms of creating Terraform resources. Next would be automatically rotate static credentials. So the idea here is to get rid of the static credentials as much as possible. So we accomplish that for all of the application accounts and their Git repositories. but still we have static credentials at basically with this user, and we have a GitLab token attached to this CI/CD authenticator repository. And another improvement for the future would be using IAM Access Analyzer API to provide or to create least privilege policies for the deployment roles based on their previous activity in CloudTrail. And scalability. So this approach works if you don't have too many accounts. Once the number of accounts grows further and further, it might become a bit tedious to maintain the mapping file. So it can also use some automation. Alternative approaches to that, you can move the automation to AWS. By automation, I mean the Python script. So it can be a Lambda function. You can, for example, store the mapping file in a DynamoDB table. What I especially like in GitHub, so not GitLab, but GitHub, this is a new feature where you can actually create an OpenID Connect provider in your AWS account, referring to GitHub, and then you can create a role in your account referring to that OIDC provider with certain conditions where the value of this variable is equal to your repository. So the complete the hassle of the mapping file would be somehow solved by this approach. That's actually all from my side. I hope you enjoyed the presentation. If you have any questions or feedback, I'm all ears. Thank you again.
We are one of Deutsche Telekom's brands in Hungary. We are Deutsche Telekom IT Solutions. Welcome and sign in. Let's see who we are and what we do. As one of the largest IT employers in Hungary, we have campuses in 4 cities. Would you like to work from home too? You will have the opportunity to do so with us. Although 29 nationalities work with us, we always find a common language. And you will have the opportunity to get the most out of yourself in the position that works best for you. Having a supporting, tight community in our company is essential for us, and we are building this community offline and online with cooking, book, or esport clubs, and our online year-end event.
I would like to remind you that these are the values that connect us as colleagues and as people. This is what we signed up for.
Sustainability is of great importance for us because we believe that only sustainable development is worth pursuing. Thousands of training opportunities support our colleagues in their professional growth. Click Apply and open a new page with Deutsche Telekom IT Solutions.
Okay, we're live from the funny farm.
My name is Tom Erik Støver.
And I'm Kim Bredse.
Where to begin? You usually do the story.
Okay, I'll try. Me and Tom Erik, we known each other since high school, and we both have the same kind of interest in IT, so we worked in IT together for a long time.
Kim told me at some point he wanted to go to this evening school for agriculture, and I said, well, I want to go too.
That led up to our starting to work together on the bees and the IoT, and now we're basically working after hours with the BIoT solution.
We do a lot of stuff together.
Yeah, we do.
As a society, we've moved so far apart, especially kind of bridging the gap between where the food is produced and the person is actually eating the food. Honeybees pollinate around a quarter of all agricultural crop. With BIoT, I think we can make that connection again.
Welcome to my farm. It's a Norwegian farm. We're located about 45 minutes from Oslo.
What are you growing over there? Oats?
Oats, yes.
So we have some sheep and pigs.
And here are some of the beehives.
In Norway, at least, if you're a beekeeper full-time, you have 250 beehives. If you're going to do the job properly, we're going to inspect everyone once a week during the high season.
And we have to open each hive, and it really disturbs the bees. We wanted to do it a better way.
We started looking into how can we do that checking in with the bees without actually opening up the beehive, meaning putting sensors inside, camera, microphone. We measure the weight of the whole hive, temperature, relative humidity, CO2, infrared spectrum, and volatile organic compounds. We use all the data that we collect to have the beehive tell us when it needs something to be done with it. The natural next step for us was, if the beehive can tell us when something needs to be done, can we also make the beehive do that thing itself?
During the winter, the bee colony gets kind of small, and then as the spring and summer comes, it gets bigger and bigger, so it needs more space.
So in traditional beekeeping, you would have to add space incrementally throughout the season. In our vision, we would have all the boxes there, but we would have mechanisms to make that space available to the bees. We have these small, inexpensive computers called Raspberry Pi installed in each hive. They receive data from all of the different sensors in the hive. Then we use AWS Greengrass to make all these pieces work together and connect to the cloud in an efficient way. Greengrass also allows us to process the data and use machine learning locally in each hive.
When the beehive can do the operations itself with the cloud at the edge, we don't need to transfer as much data, and we can just make the beehive very smart, and it's cool.
I think BIoT is about connecting the people to the beehive.
Machine learning, it's the reason why we can do this.
You can experience bees while in the city, basically. You can own a beehive, and the beehive can be out in the countryside.
The disconnect in something so essential to life is, it's a worry that's been growing in me for many years.
With the BIoT solutions, if you have some space, you can have a beehive, and the beehive can take care of itself. That potential in technology is really exciting.
Hello everyone, my name is Árpád Jorzsits, and this is the panel discussion of the AWS Day Budapest conference. Before we start, I would like to tell you that you can ask questions via menti.com. We would be happy to hear your voice, and you can find the code in the chat window. All questions will be answered afterwards on our website, and let's get started. I'm here at the virtual studio surrounded by experts from all over the world, and let's have a quick introduction round with a small twist. Please, colleagues, introduce yourself shortly and tell us what is your favorite part of your job you're really passionate about. And Darko, if you may start.
Okay, so my name is Darko Mesaroš. I am a longtime builder, developer, systems administrator, engineer, all of those fun things. My main passion was to automate things, automate them safely, and see things go at scale. I happen to work for Amazon Web Services as a developer advocate. I'm based in Berlin, Germany, but I'm originally from Serbia. And my favorite part of my job is the ability to talk to developers, engineers, builders out there to kind of get their feel on things, to be your advocate per se, to get your voice heard within Amazon Web Services. So I love being, I love screaming into the camera, but I love more being actually in person at an event. So let's hope that comes back soon.
Cool. Thank you very much for being us with here. Who would like to be the next one?
I can go next, I think. So my name is Gunnar Grosch. I am also a developer advocate at AWS. I am based in Sweden and mainly covering the Nordics and the Baltics. And it feels like I'm copying Darko a bit here, but I've also worked with tech for, well, way too long, it feels like, 20 plus years by now. And I've focused quite a lot on reliability, resilience, and hence the session I gave earlier today on chaos engineering. And what I love most about this job is interacting with builders in any capacity. It can be virtual, it can be physical, in-person events. Every chance I get to work with the community in any ways, that's definitely my favorite part of the job.
Thank you very much. So, Karol, which of you would like to be the next one?
I can go next.
Yeah, go ahead.
Okay, thank you. Hi, my name is Csaba Szegedi. I work as a solution architect at Deutsche Telekom. I also work as an AWS authorized instructor, and but actually my favorite part is when I can be creative, like creating POCs. I also like to investigate problems and ramp up some cascade problems. Why is that security problem? Why is that costing money? So these things are which are really making me passionate about my job. So yeah, I really love my job working with AWS.
Cool. Thank you very much. And Karol, last but not least.
Hey, hi. So first of all, apologies for my technical problems. I unfortunately cannot start my video, so you will have to do with audio unless I fix it along the way. So again, thank you for having me. My name is Karol. I am based in Slovakia. I'm working as a lead solutions architect for Deutsche Telekom IT Solutions Slovakia. My favorite part with about my job is so what I like the most is, or about the cloud, is that there are often multiple ways how to achieve a goal or how to fulfill a requirement, and basically finding the best way to do it. So the most cost efficient, most secure, most scalable, or the one that fits the customer the most. So that's exploring and trying out, also doing some POCs. So yeah, finding the best fit for the requirements.
Thank you very much, Karol. It's still very good to have you, in this round, even without the cam. And
Thank
now,
you.
colleagues, let's move forward a bit and go into the details. The first question would be to the round. With all the experience you have gained with cloud computing during the years, what do you think? What was the biggest blocker of cloud adoption for companies five years ago, and what is it now, if there is any at all? Darko, would you like to start?
I always like to start when it comes to difficulties in adopting technology are most not related to the technology itself. When the technology becomes mature enough to be adopted, it's there. The problem I've seen is people. Right? I've worked with companies on a couple of their cloud/DevOps transformations, and the main blocker I see here is just the ability to educate the people and inspire them that, hey, this will make your life better. This is not something that's here to replace you or whatnot. It's here to make your life better. And I see this as a potential hurdle when it comes to adopting the cloud, because like myself, I am a person who loves my physical hardware. I love my servers. I love all of those things. But I wouldn't use them in production now, right? I would rely more likely on the cloud so I can focus on the more important things. So, and I'm sure my colleagues here can share the similar experiences when it comes to I wouldn't call it convincing, but inspiring people to move on to the cloud is something that can often lead to bottlenecks.
Great. What others think about the same question?
Well, I can add on to it. And well, I definitely agree with what Darko says. It's a lot about culture in companies, the culture that they have in how they build and run things today, and changing that culture, changing that mindset can be a blocker. But I tend to tell companies and customers I speak with to start small. You don't have to move everything to the cloud. What we often see is that companies start using the cloud in small ways, which is often successful. They can start doing POCs, as mentioned before, and perhaps starting out with development environments or staging environments, things like that, and then start moving workloads to the cloud. Because then you're able to start changing your culture, you start gaining skills, and you gain confidence. And it's a lot about confidence to learn how to do things and do them in a correct way.
The cloud initially looks very scary, right? I think everybody can agree. Like, you look open up the AWS Service Console, and it's like 175 plus services. I don't know the number yet, but it can seem daunting at first. You're like, I have to learn all of this now. Yeah, and when, as Gunnar says, you slowly move on to the cloud, you start doing proof of concepts, you start doing development, you start this kind of a strangler pattern when it comes to move, and this is where people get more comfortable and more enthralled by the benefits of the cloud.
By mentioning POCs, Csaba, is there anything you would like to add to this topic?
Yeah, actually, I can fully agree with the colleagues here from AWS. It's not about technology. Yeah, I had once a colleague who were just asking then, is it possible to do these things? Everything is possible. It's there. You can use that. And actually, I personally have experience with companies, projects who didn't had yet trust. So this is one blocker, I think. Trust. Because it's somebody else's computer. It's not my computer. I don't own the hardware. The other thing is, legal stuff. Is it allowed that I put my data there and migrate to AWS? So it's not related to POCs, but it's project. It's persons, projects. That's more the blocker.
And I think for that last part, having these references, customer references that have done the same thing before, being able to see them, and we do our best to show off examples of customers doing it from different verticals and industries, seeing that they've done it before, for instance, in banking, fintech, whatever the vertical is, see that it's possible to actually move to the cloud. You don't have to have your own data center or run things on premise.
That's the best way to show that AWS can be trusted. And I think these big companies had their own compliances lawyers. So just go there, read the SLA, read the contracts, and see that it's possible. You can trust AWS.
Yeah, actually, with these references, that's a really, really good point, because I think it's not only about the verticals, but it's also about who the companies around you in the same market as you are doing, in the same region, what they are doing. If everyone is going to cloud, I think it's also a good idea to think about why I do not go to cloud. Maybe if it really makes sense. Also, if there is support from the cloud service provider in the region, that's also very good. Like we have you guys in the central and basically in the Europe. So that's really helpful to move it forward.
Absolutely. Again, just the fact that customers who do similar things as you or have moved to the cloud. One of the questions I always got, like, I go to a conference and somebody says, like, yeah, but you can't run a bank on the cloud. I'm like, oh yes, you can. Please check out these people who run the bank on the cloud, and that is just a thing. It's more people have adopted the cloud than you actually think. So that's usually a great way to kind of say people, yeah, it's fine. And if you want some more hard proof, we have all the fun certificates when it comes to certifications, when it comes to AWS, your HIPAA compliances, your PCI stuff, your C5 in Germany, and all of the fun things out there are, well, I think AWS as a cloud provider has the most certifications when it comes to those things. So compliances.
Indeed, for a few customers, having these kind of industry-specific, certificates, solutions are key. So this is their, let's move forward a bit, and let's talk a little bit about 2022. And my question would be, what do you foresee? Which cloud areas are going to be in the focus next year? And I'm just giving you some examples: cloud security, cloud governance, but that can be many more. Gunnar, if you would like to start.
Yeah, well, to begin with, security is always going to be the most important area. It is always the most important area in cloud and for us at AWS. So that's definitely going to be one of the focus areas. But other things we see, and perhaps not new for 2022, but we see a lot of work around machine learning, continue with machine learning in different ways, that more and more companies are adopting machine learning and artificial intelligence by making use of these services that really makes it easier to get started using machine learning for whatever the use case is, or even using those fully managed AI services to everything from translation to perhaps forecasting, modeling, and things like that. Another area where I see a lot of things happening is around analytics. Companies are creating more data than ever, and making use of that data is something that's becoming more and more important, because we live in a world where you have to make decisions based on what's happening within your business. So making use of data lakes, gathering all of your data, and then using the appropriate services to then understand that data and be able to make decisions. That's something that we see a lot of growth in right now. So two areas.
So security and data, right? Or is that the case, Gunnar?
Maybe it was three then.
Three.
So
machine learning,
analytics, and machine learning.
Yeah. No, I would agree with data analytics, because if you look at the past, right? When you have your internal systems which are not scalable, and to process such amounts of data can be very, very daunting. So having the ability to scale out and do this very elastically to process the data can get you a lot more insights into how to run your business. So I would definitely say wrangling your data or understanding your data better is a trend right now to in the cloud, so for sure. And just to add, security, absolutely priority number one. Anything you do needs to be secure because of that data. A lot of that data is very confidential, very private. So make sure to implement security in every step of whatever you're doing. So from developing code to building infrastructure to actually doing everything around it.
Yeah, and the key to that data, sorry, just quick, the key to getting that data and getting analytics out of it is just store the data. Make sure to create your data lake using Amazon S3, for instance. Just gather all of your data. Previously, a lot of companies, they had a lot of data, but it was siloed. So they had something in a specific software, they had something somewhere else in some logs. But just starting to create and gather all of that data, that's the first step to making sense of it.
Yeah, so there's always the business part where the business wants to have some insights and use the data and make some value out of it. And there is also the security part, like you guys mentioned, which is always super important, because the more services you use, the more combinations of services, the more functionalities of the services you use, you have to secure all of that. And the more users you let deploy resources to your cloud environment, the more effort you need to then invest to actually make it secure, because if your data get leaked, then you are done. So that's for me, that's of a crucial importance to have that infrastructure secure as much as possible, like defense in depth. So like every step you do, make sure it's the most secure as it can be.
And I would say also the cloud governance part here comes into play. The cloud is an ever expanding thing. It's never a single AWS account. It's never a single EC2 instance. It's usually multiples of those things, maybe multiple data lakes even. So having the way to govern all of that, to set up guardrails and controls and monitor for things and observe stuff, what's happening, is very key to keep your chickens in line, right? As I say, so keep everything in check just to make sure nothing bad is happening. So that's also a key part of securing your systems.
Csaba, is there anything you would? Oh, sorry.
Yeah, just. Security should be job zero, what usually say. So that should be the main focus. And as we were talking about trust, what's the best way to earn people's trust? by showing that it's really secure using your solutions. And yeah, regarding the data, I also agree. As you could see now, bees are producing data. So IoT is there in the break. You could see those bee IoT. And everything is producing data. Cities, smart cities are built, and all that data needs to be stored, analyzed. So yeah, AI, machine learning, big data. I see these as focuses.
Because you are mentioning a lot of services, and at least half of those are more complex, so they are more referring to coming to support different refactoring scenarios, or when customers really need to adapt their existing application layer and make them, for example, AWS compatible. And just a quick question to the colleagues coming from T-Systems, do you see that appetite on customers level? Are they there yet, or they are still preferring more, the simpler scenarios, lift and shift, for example, using compute, using storage? How do you see that?
Actually, what I see with cloud, you have these lift and shift scenarios, and on one side you have the EC2 instances where you have really availability to go inside and configure your operating system. And yeah, the easiest way to migrate there your already running applications. On the other hand, you have the serverless solutions where actually you need to write cloud native solutions. I would put in the middle the containerized solutions where you are working with containers. So where I really saw the appetite is on the EC2 side, so simple lift and shift, but also lots of containerization stuff. So Kubernetes, which I also was showing you, lots of projects are moving their containerized environments to AWS clouds, and yeah, different solutions are available there. So yeah, there is an appetite. Actually, I'm working with internal customers more, but yeah, I could see that projects are willing.
Okay.
Yeah, it depends on the particular use case, obviously. So whether something is already running somewhere and you just need to migrate it quick and dirty, or if you have time and effort to make the best of the, let's say, the managed services on AWS, which then in long term will save you a lot of time on operation in the future. So that's also possible. But if something is being built from the scratch, so the greenfield, I saw a lot of nice projects internally built on serverless, and the guys really created a lot of value in a very short time because they use many services, they use serverless, they have minimum operations around that, which is really beneficial for the business.
Ultimately, lift and shift is the fastest way to go to the cloud. However, you are basically missing out on all the cloud native benefits out there, right? So the cloud is not just a place to put a server in. The cloud is a place where you can evolve your application, your workload to be much more, let's call it modern, but much more cloud native or more optimized.
Fastest, but not always cheapest.
Mm-hmm.
Absolutely.
But also, I think it's important to say that there's no right or wrong way of doing it. It's just a matter of doing it. I think that's the main point. If you do lift and shift, well, then you should start thinking about how to move to the next step. What are your next plans? Because you don't want to be stuck in what you had previously just in the cloud. You want to think about how can you leverage all of these fully managed services, perhaps move to serverless, and you can do that in small iterations, simple parts, smaller parts of your application one by one.
Having a cloud strategy on customers end is definitely very important. And my suggestion would be to move to the next question, because we have some. The next question would go to the colleagues from AWS. Who are the most relevant reference customers or AWS currently? How AWS positions, for example, like Netflix on AWS service, how does it work? Because you have some, huge customers who are influencing, I guess, the whole platform sometimes. And anyone can start.
Well,
go, Gunnar. Yeah, do it.
Yeah, happy to start. And I think we talked a bit about references earlier as well, and I think references are super important. But I also think that you should look at references that make sense. You shouldn't perhaps look at the biggest companies that have been in the cloud for ages now, as long as the cloud has been around. But rather look at the ones that make sense for you. So, for instance, we talked about banking before, and in the Nordics, for some reason, we have a lot of companies, especially in fintech, in banking, that have moved to the cloud, and several of those are great references. For instance, we have a company called Northmill, which is a bank that's fully in the cloud today. They've built their platform using serverless, but they started out on-premise as an on-premise bank. I think they started their move to the cloud in 2013, but decided to make a move from their on-premises solutions into the cloud and build a new platform using serverless, which in turn then has given them the opportunity to scale as needed. They are really building a platform that can scale up and down as the need is there from their customers. And besides them, I think Klarna is a great example. I'm not sure if Klarna is big in Central Europe. Perhaps they are, but they are doing a global rollout. Klarna is I guess they've surpassed the unicorn phase and are now in a regular growth phase. Also all in on cloud, left their on-premises data centers and are now a bank fully operating in the cloud.
But let me mention some of the customers we have in Hungary, right? Euronics. I used to be a customer of Euronics. Like, it's a well-known retail store where you can buy home appliances. One of the things when it comes to these retail stores, especially on the online shopping, is that you have specific events like Black Friday and specific sales throughout the year. The problem there is when you have these events, you need to have the infrastructure to support those events when you have thousands of customers bombarding your retail platform at the same time. So Euronics has switched to AWS, and they're actually adopted the entire scalable and elastic model of the cloud. So they can basically handle all the spikes in traffic, but they also save money on the troughs. When there's no traffic, they reduce their scale to a minimum, hence saving costs. I recall the number was something like 37% in the first year since they moved to AWS, which is pretty impactful. So that's one of the customers in Hungary that I like to mention a lot. And even though they use some of the baseline services like EC2 and autoscaling, it still has made quite an impact in the way they do business. So pretty happy about that.
And I think that's really great, talking about how customers are able to leverage the cloud in that way. We've been through quite an extraordinary time these past, 18 months or so. And there are a couple of good examples of companies making use of the cloud for that as well. And there's a big airline called Finnair based in Finland who did an exit out of their own data centers and moved to cloud in AWS pretty much right before the pandemic hit, which, as we know, airlines have had quite a rough time because more or less no travel for 18 months. So they were able to then scale down their environments by being in the cloud to then be able to adjust for that low flight time or whatever we call it. And on the other side, there are companies like a company called Mathem who works with food deliveries. They instead had a spike during the pandemic because everyone was at home, needed to order food and have it delivered at the door. So they instead made use of a serverless platform, meaning that they can handle whatever load was thrown at them. And it was a huge load when people needed to start ordering food from home.
Okay, colleagues, thank you very much for the great examples and your great comments. Let's move to our next question then, which is more about, strategy and mindset at the company or customer level. And the question would be, how ambitious are your customers delivering innovation through IT? And what opportunities do you see Darko, if you may start.
So Gunnar mentioned this in the beginning. Like one of the key parts of the cloud in 2022 now and beyond is machine learning. Now, the term machine learning is being thrown left and right, but it is definitely one of the things that you need to take into account when you're doing something. So what we see customers do is that when they're building a product, one of the first questions they ask is, can machine learning help us innovate in this product, workload, service, whatever we have? And with the scale of the cloud, with the one-click nature of specific machine learning services, we see more and more customers innovate on that side, using the power of machine learning, which in my honesty, I'm not a machine learning expert by any means, but I personally benefit from machine learning. So I see that as this amazing new frontier where we see customers build new things, even if they do not have like data scientists or like basically very smart machine learning people in-house to do these things for them, because we offer these services, well, machine learning services for them to use things such as recognition, where they can do computer vision, transcribing, where can do some things with text, voice to speech, text to voice, and all that kind of stuff. So a lot of things happening out there with machine learning, and I see that as one of the biggest innovative paths with our customers.
And I have a great example there. I think a lot of you are familiar with the game Angry Birds, created by Rovio. And they use machine learning to create new levels that are based on machine learning models. They can create levels that are adapted for your usage. They see patterns in how customers are using the game and are then able to create new levels based on that. So a very simple use case for machine learning, but that has a great impact on their users.
Thank you very much. Karol, Csaba, is there anything to add?
So from my point of view, if a company wants to innovate, it needs to innovate through IT. And if you want to innovate through IT, I think you should use the measures which will help you to innovate as fast as possible. So from my perspective, that's also cloud and all the variety of the managed services, where you can really create value in a very short time, or at least you can start prototyping and see if what you are doing can bring some value, and you can do it in a very short time. So this is in general the approach that I see and is really viable and I think successful.
What I think, and maybe we should also have a focus on people again, because the technical peoples which I met during the projects where I work with AWS, they were really passionate, and people who start to work with cloud environments will have to know from the beginning that this whole journey will come with lots of learnings. It's continuously evolving, the whole environment. New technologies emerge for machine learning, like you said. Actually, for small projects, you don't even need data scientists at first. Just go there and grab the trainer algorithm and teach, feed in the data, and you have results. So yeah, but people are willing to learn. What I met that they are really like these new things and passionate about this whole environment.
Engineers like new and shiny things. So no matter how long you've been in this job, you like to see a new piece of technology, like I get to do things. So yeah, I think that's a fun thing. At least for me, I'm very excited when I see a new technology, even if I do not know anything about it. I like to tinker at least a bit to see if I can figure it out.
And I think that's why we see so much innovation around serverless these days as well, because it is the developer is able to simply write their code and deploy that code and have it running in production in seconds or minutes. And that fosters an innovation culture, I think, having that opportunity.
Thank you very much, colleague. One last question we have, and that question goes to Karol and Csaba. You work for these systems, so the question is, what does these systems, think about AWS, but also, other other kind of setups. We call them hybrid cloud solutions. When customer is still on-prem but started its cloud journey, how T-System sees that angle. Karol, if you would like to start.
Yeah, so I think it's important to take the best out of each approach. So something really can and needs to stay on premise because there are some historical legacy reasons and workloads why something it doesn't make sense to migrate it at any cost to cloud because it wouldn't make sense financially or from any other perspective. Then there are maybe some sorts of data which you cannot move to cloud either or to public cloud. So in that case, you might want to stay within the private cloud. So we also have offerings for that. But with all other types of workloads and scenarios, I think it makes sense to go to the public cloud, and then it's a matter of choice. Which one is the most fitting for the requirements? So yeah, it's important to treat it reasonably. Yeah, so to think about the requirements and yeah, make a good decision. So to pick the best out of these options.
I want to say something here when it comes to hybrid cloud. Unless you're cloud native, you're most likely hybrid cloud. At one point in your cloud adventure, you're going to be hybrid. Rarely when it happens that a customer just takes everything in a single night and moves it to the cloud, right? It usually goes in a much slower manner. So even if you don't think you're a hybrid cloud solution, at one point you are or will be or have been. So I think it's just a matter of fact. And we need to support customers with things like direct connect and data migrations and all the fun things around when it comes to having stuff in the cloud in a hybrid way. So your systems managers, your way to run AWS outposts on premises and all that kind of stuff. So I think it's quite valid to be aware that the hybrid cloud is a thing.
Yeah, I fully agree. And T-Systems is the company which supports both solutions. So we have lots of solution architects supporting these internal and external projects. But yeah, we never stop if somebody says that okay, we don't. We cannot use the cloud, or can we support hybrid solutions? And yes, we support that because it's a valid use case. Like Gunnar said, go step by step. Maybe you are just in the middle of the migration. That's why you are using hybrid solutions. And finally, you will reach native solutions in the cloud. But maybe you will always have hybrid solutions because you have embedded systems, you have on-the-field system working with the cloud. Or yeah, like Karol said, data. You cannot move your data outside of your hardware because that's a legal requirement. So yeah, it's a valid use case, and both AWS supports it with Outpost, having the AWS in your data center in AWS technologies hardware. So yeah, it's valid, and we are supporting it.
And that's a support that's growing as well. We talked about Outpost, but we also have ECS Anywhere, for instance, where you can run our container system on your own hardware, pretty much any hardware. And we have solutions like AWS Code Pipeline for your delivery pipelines, and using Code Deploy to deploy to your own services or your own servers that are on-premise, or a systems manager and help manage your services that you run in your own data center, for instance.
Great. Thank you very much for being here. That was all the time we have for today. We are finishing our panel discussion. And I would like to thank you, everyone, for joining us today. I hope you enjoyed the discussions and the whole conference as much as we did. And see you next time. Goodbye, colleagues.
Bye.
Thank you. Bye.